Well, good morning there, physics students. Hey, it's Friday, April 24th, and we're going to look at a roller coaster. So, I'm in my dining room. I've got this roller coaster set up. You see there's the train is waiting at the top of the first track, and we've got a big hill coming down. Gee, we got a photo gate set up at the bottom of the hill. And then we just come up a hill, and probably not the safest roller coaster to ride, although I will tell you from experimentation, you wouldn't be jumping off the track, you would just fall back into the valley. So, pretty short ride, probably be kind of fun. So, we got some measurements, and I took pictures for you. I want to point out a couple things. My meter stick wasn't tall enough. So, I have just a block of wood underneath my meter stick, so any measurements you're looking at right up on the top, you're going to have to add in the length of that block of wood, and I took a picture of that also. I had also put the roller coaster train at the bottom of the hill, so let's let her... So I had put the meter stick in there and measured also, or gave you pictures. You want to use the same reference point wherever you're making your measurements. And, you know, spoiler alert, I lined up the pictures with the top of that little dowel rod that I have attached to the roller coaster train. You see that the dowel rod goes right through the photo gate. I'm a little bit concerned that the way it tilts might make it take a little bit longer to go through the gate. I really haven't sat and analyzed that to try to figure it out. Hopefully the difference is minimal. So let's look at the display for a computer a little bit. I finally figured out where you got to go to change the settings. I know there's some nasty glare on here, so I don't know if we'll be able to see this. We'll give it a try. Down in this corner, it has mode, photo gate timing, and when I click on that, we bring up this screen, and it's preset for a veneer picket fence, but I can change that, and there's an option here for just doing speed through the gate. And when I do speed through the gate, it has the flag width, and it's preset to 0.05 meters. Normally, I had actually tried to measure that dowel and left you with pictures for the measurement, and I'd leave you read the pictures. But since I can plug that in here, I'm going to change this. When I measured, I came up with 0.016 meters. I want to make sure I got that correct. I'm going to go 0.016 meters. In other words, 1.6 centimeters. And I'm going to click Done. And on this screen, I want to get rid of the graph and just go with the table. And so now we have less states. We have just the time and the gate state, and then it has gate time and velocity. So this should be calculating based on the 1.6 centimeters going through there what the velocity was when it went through. Now you saw that the roller coaster, when it comes down, is going to go back and forth through it, so we'd want to use just that first velocity, and I'm going to do several runs of that. Basically, you're going to look at your lab, but what we want to do here is look at the change in potential energy going from the top of the hill to the bottom. We're going to figure out what that change in energy is based on that change in height, and then we're going to calculate the kinetic energy of the roller coaster train at the bottom of the hill based on its mass and its velocity. And I'm going to ask you to do an efficiency calculation comparing the two. So if the height of the hill is how much energy we start with, and its kinetic energy corresponds to the energy it has at the end, you're going to find out it's less. And by doing the ratio of those, we should be able to find the efficiency of the hill. So that's just kind of a little summary. I'm going to take a video and collect some data for you and share this all. And hopefully we're going to have everything that you need. All right, I'll get to it.